Hello everyone, welcome back to the brand new video series. This is Mr. Nisar, your maths guru. You can read more about me on the screen right now. In today's session, we are going to start with an exciting topic, that is linear inequations. So get your notebooks ready and let's dive into the world of mathematics. So linear inequations. Children, you have heard about the equations, okay? But what is the meaning of inequations then? So equations means you are aware that will have an equal to sign. Okay, this is the meaning of equation. So children, can you guess? Yeah. So let me write here equations. Yeah. We have an equal to sign in that. So what is the meaning of inequations then? Suppose when the two quantities are not equal, then what are the possibilities? Then what may be the relation between that two quantities? Can I say that the relation may be, if they both are not equal, either x may be greater than y, x may be less than y, yeah, or x may be greater than equal to y and x may be less than equal to y. Okay, so when with the two quantities, when the two quantities are not equal, so here arises inequations. So they have the four conditions. Let's move ahead and try to understand in detail what is the meaning of linear equation and what are its real life applications. Where do we apply linear equations? So let's move ahead. Yeah, if x and y are the two quantities, then both of these quantities will satisfy any one of the following four conditions. That is the relations which I was talking to you in the previous part. Like what may happen? X may be greater than y, x may be greater than equal to y, or x may be less than y, or x may be less than equal to y. Okay, so these are the four possible things, and these are nothing but these are called as inequations. Okay, yeah, so in an equation, these signs, we have these four important sign. This sign which we will call as greater, then this is less than, then this is greater than, and see this downside, so it's called as greater than, equal to, and we have less than, equal to, are called signs of inequality. Okay, so if a, b and c are the real numbers, then each of the following is called a linear equation in one variable. See here, I have given you few examples of linear equations in one variable. Linear inequations. Okay, we are talking about inequations, not equations, so be very careful. So here I can say you ax plus b is greater than c, so this is an inequation. Okay, here greater than is there, and how to read it? See, this is something important, each and everyone should know how to read it. So I have written here ax plus b is greater than c. You can see over here it is ax plus b. How to read this? Now see children, it's something very important. Many students don't understand this, that which is greater and which is smaller. So something very easy thing we'll say. See, you are aware about the crocodile's face. Okay, so like this is the crocodile's face. So which this face is towards this side, so it simply means that this side is greater. So wherever is the crocodile's face, so you can say that that side it is greater. So here we have the crocodile face towards this side, so I can say here it is ax plus b is greater than c. Now here you see this crocodile face is towards c. Okay, so we can say that this side, okay, so this side is nothing but this is the less than side, because c here it becomes greater, so this side automatically it becomes less than. So can I say here it is ax plus b is less than c. Okay, ax plus b is less than c. Let me erase the ink on the board. Yeah, then let's go ahead children. Then we have here, you see this sign here, it's greater than, also the crocodile face is towards this side, so it's greater than. Even we have something down, yeah, that's equal to, so we read it as ax plus b is greater than or equal to c. And then we have, you see this symbol. Now again, can you say me what you can say about ax plus b here? What you can say about ax plus b there? I'll just take me my upside. Yeah, now it's your time to answer. Yeah, ax plus b is less than or equal to, don't forget this equal to, less than or equal to c. I hope you are able to understand the signs of inequality. Okay, so we have here four important signs. Let's move ahead and try to understand what are the real life applications of linear inequations. Where do we study that? So yeah, real life linear inequalities. Okay, everyday maths in action, this is something very important for us to know. Okay, linear inequalities help us make smart choices daily in India when budgeting rupees 5,000 for monthly expenses or calculating how many items to buy when each costs 250 rupees. We use inequalities without realizing them. This I am going to explain you in detail in the upcoming part. Okay, how we use inequalities without realizing it. Let's move ahead and understand it with the help of example. Something very interesting I have written for you children on the board. Money matters. Okay, budgeting with maths, this we do in our daily life. Now suppose you have a budget of 1500 rupees, so you can spend 1500 rupees. Now you are at the petrol pump, do understand this. Now the price of cost of each liter of the petrol is 100 rupees. What is the price of 1 liter of a petrol? That is 100 rupees. Now the question is to you, how much liters you can buy? So how much liters of petrol you can buy right now? Come on, say me. So you'll say that yes, 100 rupees per liter means 1 liter is going to cost you 100 rupees. So you can buy, yes, the answer is 15 liters. Now what we did here, how we applied inequality here, can anyone say me? Yeah, I have written over here children, if petrol cost 100 rupees for 1 liter and you have 1500 rupees in your pocket, how many liters can you buy? We write the as 100 into liters is less than equal to 1500. You see this line. This is 100 into liter is less than equal to 1500. It means what? 100 into, if I need, if suppose I am going to buy 15 liters, so it will be what? 1500, and this value should be always less than. Now you can buy 14 liters, you can buy 13 liters, but you have the budget of 1500, so the condition will become here in it will be less than equal to 1500. So you have the money to get the petrol before that only. Okay, you have to buy in 1500, less than that or equal to that, you cannot buy more than that. So it will be 100 in 2 liters. Now here I have written 15 liters. Now you can consider it as x also, 100 into x. Suppose you want to buy 2 liters, you can buy here 3 liters, you can buy here. But what is the maximum number of, what is the maximum number you can put it over there? How much is the maximum quantity of petrol you can buy? So you'll say that we can buy only 15 liters. Why? Because our budget is less than equal to 1500. Okay, what is the minimum? Minimum we can buy like less than 1500 and maximum is equal to 1500. I hope the concept is quite clear too and you are able to understand how we are applying inequality in the situation. Let's move ahead and try to understand one more example. Yeah, see one more example I have written for you. Rent, can you afford it? See what I mean to explain you here right now is linear inequalities. Okay, now see rent limit. See, this is something very important. Okay, your rent should not exceed 15,000 monthly based on what you earn. See, this is a condition for you. Your rent should not exceed more than 15,000. What is the basic rule? Rent should stay below 1/3 of your, see this is the rule which we follow. Rent should stay, this is the basic rule, stay below 1/3 of your monthly earnings. So whatever you earn, your rent should be below 1/3. Okay, 1/3 of your earning. Now suppose your pay is 45,000. Monthly you are getting a salary of 45,000. So you can find your safe rent amount. So see, for this I have written a simple maths here children. This math shows if your housing is affordable, your rent should be, come on say me, your rent should be less than or equal to 1/3 of your income. Your rent should be less than or equal to 1/3 of your income, not more than that. Have we applied inequalities here? Yes, I hope you are able to understand where we apply the inequalities. See, we apply inequalities in the daily life without realizing it. Let's move ahead and find out a few more examples. Yeah, we have something very interesting for you children. Read what is given to you on the board. Speed limit 65 mph, miles per hour. Okay, now how to write inequalities for it? Yeah, speed limit. Now see, what is the speed limit here? This we will be writing in terms of, come on, inequality. So can I say here speed is less than, the speed should be either less than 65 or equal to 65 mph. So is that clear to you? So here we applied the inequality. Now the driver's license, how you'll say about the driver's license? The age should be either greater than 18 or equal to 18. What we are talking right now here? Inequalities. I hope it's quite clear to you. And traffic fine, I have written here 5,000 for violation. Okay, if these conditions are not satisfying, then you have to pay the fine of 5,000 for it, for violations. I hope you are able to understand the inequalities concept. Let's move ahead for the next example. Yeah, this is something very interesting I have put on the board, children. Time crunch. Can you finish on time? Now see, the current time is 12:40 p.m. Okay, and this is a situation it's given to you. Now available time, now you see you have a class at 1 p.m. Okay, so 12:40 is your current time. Now available time will be what? Come on, say me. The available time is, it's less than or equal to 20 minutes. So here what is the use? What we have used? Again, linear inequations. Okay, so I'll just, yeah, I'll come aside. Fine. So now you say me here. So lunch break is for needs, and you went on the canteen and there you need 30 minutes. So the question is, can you finish on time? Okay, so next class starts at 1 p.m. So if you are late, it's 50 rupees late fees you have to pay. So the conditions are mentioned to you on the board, and I gave you time here for thinking. So can you finish on time? Do you have used here linear inequations? So the answer you have to give in the comment box. Let's move ahead for the next example. Yeah. So the next example I have put on the screen, that is safety first, watts and warning. You have seen this on the geysers, on the electric appliances. So here something is written. If you have noticed this here, 60 watt bulb warning. So here I have just given you how we applied the inequalities, children. Light fixture, maximum bulb wattage, it should be less than 60 watt. Prevents overheating and fire hazard, so it should be less than or equal to 60 watts. So you can understand this. Then electrical outlets, maximum energy cost rupees less than equal to 15 per hour. Prevents high electricity bills and power wastage. Appliance, safe operating range, it is, the range is written here. So what we are using here, I hope the concept is quite clear to you, children. Here we are applying nothing but the linear inequations. Let's move ahead and recap all the applications, all the real life examples what we have seen for linear inequation at once. So yes, summary and challenge, whatever we have studied till now. Where do you see inequalities? I have given you few examples. One was budgeting, the monthly expense, then planning, then rules like age requirements, then safety, helmet requirements and speed limits on highways. Many examples we have seen. Now it's your time and it's challenge to you. The challenge is, find an inequality in your daily life. How does it help to solve a real problem? This is the question for you. Try on your own and put in the comment box. I hope you are able to understand. Let's move on the topic, children. Children, now, yes, so children, now as we enter in the linear equation chapters, here we have few rules. Okay, to be exact, we have six rules of linear inequalities, and with the help of these rules only we are going to solve all the questions of linear equations. So without wasting time, let's start with the first rule. What is the first rule? Let's check on the board. Yeah, so the first rule we have, see, these rules are mostly the same as your linear equations rule. Okay, read the first rule. On transferring a positive term from one side of an equation to its other side, the sign of the term becomes negative. This we are doing, okay, in the linear equations. Let's see with an help of example. See children, one example I have written on the board. 2x plus 3 is greater than 7. So what does it mean? On transferring a positive term, so this plus term, if I transfer this plus term to the other side, what's going to become? The plus will go to other side. So can I say here it's become 2x. Now see, here this sign will be as it is. There will be no change in this sign. Okay, the inequality sign, plus 7 was already there. Now plus 3 went to the other side, it becomes minus 3. Now you consider this as an boundary. So this plus 3 went to this side and it becomes minus. So our first rule says us that when a positive term transferring from one side to the other side, the sign of the term becomes negative. So positive will become negative. Let's understand it with the help of one more example. Yeah, now you have to say, my children, it's 23. Here it's greater than equal to 4x plus 15. I have to transfer this 15 now. Plus 15 if I transfer to that side. So what will happen? The plus term will go to the other side and it becomes minus term. So can I say here it's 23 minus 15. Do the inequality sign changes here? No, there is no change in this inequality sign. It will be as it is. This rule is same as the rule of linear equations, what we do in the linear equation. I hope the first rule is quite clear to you. Let's move ahead to see the rule number 2. Yeah, so let's see. The rule number 2 is on the screen. On transferring a negative term from one side of an inequation to its other side, the sign of the term becomes positive. Negative will become positive and positive will become negative. Rule number 1, positive when to other side becomes negative. Rule number 2, negative when to other side becomes positive. Okay, same as in linear equation. Let's see with the help of example. You can see an example, 2x minus 3. So children, here minus 3 will go to the other side, and see here, do this inequality sign changes? No, it will be as it is. 7 minus 3 is going to go to this side and it's going to become minus, will become plus. So you have an answer 7 plus 3. I hope you are able to understand. Let's see one more example. Yeah, can you answer this to me, children? What will happen? Minus 15 is going to this side and it's going to become what? Plus 15. Minus 15, it's going to this side. Okay, this is our boundary, so it's going to this side. So minus 15 went to the other side, it becomes plus 15, and the inequality sign will not change here. In rule number 1, rule number 2, the inequality sign will not change. I hope these two rules are quite clear to you. What is the first rule? Positive goes to other side becomes negative. Second rule, negative goes to other side becomes positive, same as in linear equations. Let's see the rule number 3. Yeah, so we have rule number 3 on the board. If each term of an inequation be multiplied or divided by the same positive number, the sign of inequality remains the same. The sign of inequality remains the same. Okay, it means what? Let's understand it with the help of an example. Suppose, children, here I have an example, 4x is greater than equal to 6. Okay, this is the example, 4x, sorry, it is x less than equal to 6. I have an example, x less than equal to 6. I have read that the next line, that's why I said 4x. It's the example is x less than equal to 6. This is an example. Now children, what is the rule says here? If you multiply both sides by the same positive number, you have to focus something on this word, children. This is something very important here. Positive number. We are talking in rule number 3 about the positive number. So the sign of inequality remains the same. The sign of inequality is not going to change. Now x is less than equal to 6 I have multiplied this both the side by 4. So it becomes 4x and it becomes 4 into 6. So do the sign of inequality will change here? No, it will not change. It will remain as it is. So from rule number 1, rule number 2, rule number 3, the sign of inequality will not change. Okay, here the example is like this. X is less than equal to 6. The same example I am taking. I have multiplied here both side by 4. Okay, so the sign of inequality remains same. It will not change. I'll multiply this I'll divide this both side by 3. So divide by 3, divide by 3. Both are the positive numbers. So if I divide or multiply by the positive numbers, the sign of inequality will not change. Okay, this is rule number 3. Let's have a few more examples. Now you see here the second example. X is greater than equal to 5. I have multiplied both side by 3. Do the sign of inequality changes here? The answer is no. The sign of inequality will be as it is. Let's see one more example. X is less than equal to 2. I have divided these numbers by the 10. So do the sign of inequality changes here? No, the sign of inequality has not changed. So this is our rule number 3. Let's go ahead to understand rule number 4. So let's have rule number 4 on the screen. Yeah, if each term of an inequation be multiplied or divided by the same negative number. Now this is something very interesting. In rule number 3, it was positive number. In rule number 4, it is the same negative number. So if we divide it by the same negative number, the sign of inequality reverses. This is something very important. So here the most important rule comes here. When if someone asks you when the sign of inequality changes, so your answer should be when it is divided by the negative number, with the negative number divided or multiplied. So let's understand this with the help of few examples. Yeah, so if each term of an inequation be multiplied or divided by the same negative numbers, the sign of inequality reverses. Let's see few examples, children, here. Yeah, so see, x is greater than 5. This is the first example I have taken. Now what I did, I multiplied this both side by a negative number, that is -3. So what happened? This sign of inequality changes. It reverses. That is the concept here. Okay, so if you divide the both side by the same negative numbers, the sign of inequality will change. Let's have a few more examples. You see here. Yeah, x is less than equal to 6. I have multiplied both side by -4. So this sign of inequality reverses. So when it reverses, when it is multiplied by the negative numbers. Let's have one more example. Yeah, I'll take an example once. See, children, suppose I have x greater than 5. This is then question. And what I did, I multiplied this both side by, or I'll divide it right now. One I have multiplied, so I'll divide it. So if I divided both side by -3, this side also by -3, and this side by also -3. So when you divide this inequality by the negative number, what will happen to this sign? Yes, it will reverse. So this side, it was the greater, so it becomes less here. I hope the concept of this rule and the concept of inequality is quite clear to you. Let's move ahead to understand the next rule. Okay, so this is something very important. In the first 3 rules, the inequality remains as it is. In the 4th rule, the inequality reverses. Let's move ahead, children. Yeah, so let's see rule number 5. So what is the rule number 5 we have? Yeah, you can see on the screen the rule number 5 is, if sign of each term on both the sides of inequation is changed, the sign of inequality gets reversed. So children, have you noticed here again the concept is the sign of inequality is going to reverse. Yeah, so I want you to focus on this part. Here it is reversed. So this is the one more rule where the sign of inequality is going to reverse. So when it is going to reverse, if sign of each term on both the sides of an equation is changed. So if we change both the sign, for example, I have written on the board here -x was greater than 5. This is the example which I gave you. Now what I did, children, I changed both the sign. This minus has turned into plus, and this +5 has become -5. So in both the sides I have changed the sign. See, do remember, it's something very important. It happens when you change the sign on both the side. So the sign of inequality reverses. Now it was towards that side, so it went to this side. So when it happened, children, when you change the sign on both the sides, let's understand it with the help of one more example. Now you see it's 3y less than equal to 15. What I'll do, I'll make it both negative. Both sides are positive. I'll change it to negative. What will happen? Yeah, I change it to the negative and this inequality gets reverses. Come on, say me, what is this rule number 5? So the rule number 5, it's simple. It simply says us that if we change the sign on both the sides of the inequation, the sign of inequality reversed. So we have seen 2 rules where the sign of inequality is changing. It's becoming reverse. What are the 2? The first one was when we multiplied and divide it by the negative number. And what is the second? When we change the sign of both the terms, okay, of both the terms on the sides, so the sign of inequality gets reversed. I hope the concept is quite clear to you. Let's move ahead and try to understand the next rule. Yeah. So we have the next rule here. Rule number 6. if both the sides of an equations are positive or both are negative, then on taking on the reciprocals, so here the important keyword is reciprocal, the sign of inequality reverses. So children, if you have noticed, in the first three rules the sign of inequality was the same, and in the next three rules 4, 5 and 6 the sign of inequality was changing. So let's see here how it's changing. Yeah, I have given you an example. So see, x is greater than 5. So simply what I did, x was greater than 5, and I have taken the reciprocal. The reciprocal of x is 1 by x and the reciprocal of y is 1 by y. What happens? The sign of this inequality reverses, it changes. Let's understand with the help of numbers. Suppose I have here 4x and here I have 5y, and it is said that this 4x is greater than 5y. What I did, I have just taken the reciprocals. Come on, say me what will happen to the sign. This inequality sign will change, it become reverse. This is rule number 6. I hope the rules are quite clear to you. Come on, just revise all the 6 rules at once, children. What was the first rule? The positive will go to other side, becomes negative. Second rule, negative will go to other side, becomes positive. Third rule, if you multiply both the sides or divide both the sides by the positive number, the sign of inequality will not change, it will remain as it is. Rule number 4, if you multiply and divide both the sides of an equation by the negative number, here I am talking about the negative number, the sign of inequality reverses. Is it? Then rule number 5, if you change the sign on both the sides of both the terms on an inequations, the sign of inequality reverses. And rule number 6, if you take the reciprocals of both the terms on the inequality on both the sides, the sign reverses. I hope the concept is quite clear to you and you are able to understand each and everything. So with this all rules, let's dive into the world of exercise. Let's solve few questions related to linear inequations from exercise. Yeah, children, before solving the question from the exercise, let's see one more concept from this topic, that is a replacement set and solution set. Now what is the meaning of replacement set? See, I have written here and it's very easy to understand actually. Yeah, so a set from which the value of variable is chosen is called as replacement set. I'll give you an example, and its subset whose elements satisfy the given equation is called solution set. Now for example, children, I have an inequation that is x is less than 3. You can notice on the board, if x is less than 3, this is an inequation. Okay, right now what I'll do, the replacement set. Now here the replacement set is given to us, suppose it is a natural number. Now what is the replacement set? It is a set from where, come on, read it, a set from which the value of variable is to be chosen. So now this x value, no, I have to choose from the replacement set, and our replacement set here is a natural number. So from this natural number I have to choose the values. So come on, say me, it is said that x is less than 3. So what are the natural numbers we have? The natural number starts from 1. So it means the value of x is here 1. The natural numbers are 1, starts from 1, then 2. Here the value of x is again 2 because this x is less than 3. So it can be 1, 2. Can it be 3, children? Can it be 3? No, because here x is said that it should be less than 3. So we have the values of x as 1 and 2. We have the values of x as 1 and 2. So when it happens, this was our replacement set from where we need to take the values of the variable. Now if I change this replacement set, now see children, do understand here what I'll say you now. Suppose the replacement set we have now, it is whole number. Now you say me, what are the whole numbers? We have the whole numbers as 0, 1, 2, 3, 4 and so on. Now what is the value of x we have to take? The value of x is less than 3. So what is the first value of x? Is 0 the less than 3? Yes. Is 1 less than 3? Yes. Is 2 less than 3? Yes. Is 3 less than 3? No. So we have 3 values. This is the solution. Okay. Solution for x is less than 3, that is 0, 1, 2. and this is 1 2 is the solution for the natural numbers. I hope you are able to understand. It's very easy to understand what is the replacement set. Replacement set is a set from where we need to take the value of the variable, and what is the solution set? It is the subset of it which satisfy the given inequation. I hope it is quite clear to you. In this question, in the first example, I have taken replacement set as natural number. It means I have to assume the values of the variable of x from that natural number. In the second step, I have taken the whole number. I hope the concept is quite clear to you. Let's go ahead. So we have the first question of exercise 4th A on the screen. The first question is multiple choice question. So choose the correct answer from the options given below. For a replacement set, the replacement set is given to us. It means these values we have to take for x, that is -8, -6, -4, -2, 0, 2, 4, 6, 8. Which of the following is not? Just highlight this word. It's not. Okay, let me change the color. Yeah, so you can see here not. Okay, which is not a solution set. It means what? The answer should not satisfy the given replacement set. Now see, the first option we'll see -8. Do -8 is present here? Yes, so it's satisfying. Then -6. Do we have -6 in the replacement set? Yes. Then -5. So do -5 is there here? No, -5 is not there. So this is the only solution set. This is the only solution set which is not present in the replacement set. So this should be the answer. Let's check the second option. -6, -2, 0, 2, 6. All these elements are present in the replacement set. So this is the solution set. -8, -4, -2, 0, 2. This is also present here. So this is also the solution set. -2, 0, 4, 8. This is also present in the solution set. So this is also the solution set. But which values are not present here? This -5 is not present in this replacement set. So this is not the solution set. So option number 1 is the answer. So just I'll mark it with the yellow color. So we have the first answer of our MCQ. This is 1, which is not the solution set. So without wasting time, let's move on the second question. The value of x for, so we have to find the value of x. Come on children, let's do it. So the left hand side it's given 4 into 2. So let's multiply this. 4 2s are 8x minus 4 5s are 20 is less than 2x plus 28. Okay, see, these questions are quite simple. You don't have to worry about it. Now this is plus 2x, plus is going towards this side. What it becomes? Solve same as linear equations. So plus 2x will go to this side. It becomes minus 2x. So when the positive term is going towards the negative side and negative term is going towards positive side, do the inequality changes, reverses? So no, the inequality never reverses when we are transferring positive to negative or negative to positive. So minus 20 will go to this side. It becomes plus 20. So 8x minus 2x, we have this as 6x, and here it is 28 plus 20, 28 plus 20, it's 48. So then we have x is equal to x, then this less than 48. This 6 was in multiplication, it went in the division. Okay, so what we have done children, it's divided by a positive number. So whenever we divide by positive number, the sign will not, the inequality sign will not change. Okay, so 48 divided by 6, 6 8s are. So 8 is less than 8. Sorry, x is less than 8. Which option? Option number 2. I hope it's quite clear to you. Simple question, just transferring the values here and there. Okay, so transfer variables to one side, numbers to one side, and you will get an answer. Let's move ahead for the next question. So the next question we have, yeah, the solution set for the inequation. Now the inequation is given to us minus 2x plus 7 is less than equal to 3, and x belongs to real numbers. Okay, so I'll keep this minus 2x on this side, plus 3 will go to this side, becomes minus 3. So it will be plus 7 will go to this side, becomes minus 7. So 3 minus 7, and 3 minus 7, it's nothing but it's minus 4. And I have here minus 2x. Okay, now children, see what I'll do. I'll transfer this minus minus 2. This is in multiplication, it will go to this side in division. So now can you say me, the sign of inequality will change here or not? This is the question to you all. I have transferred this minus 2 towards this side. Okay, or you can say that I have divided both side by minus 2 minus 2. Okay, on left hand side also and right hand side also. So come on, say me now. Do the sign of inequality changes? Yes, the sign of inequality will reverse. Okay, it was towards this side, now it went to this side. Why? What was our rule number 4? Come on, repeat the rule number 4. Rule number 4. Rule number 4. When you divide and multiply both side by the negative number, what happens? Negative number, the sign reverses. The sign reverses. Rule number 4. So here we divided it by the negative number, that is -2. Okay, it was here -2, it was in multiplication, it went in the division. So you are actually dividing it by -2. Now see, you may understand this thing by in this way also. Actually the good way I can say here, actually it should be in this way. When you are doing these things, no, that if I have to transfer this -2 towards this side, the actual meaning is divide both side by -2. The actual meaning is divide both side by -2. Okay, now this will get cancelled and here it will be, yeah. Now you see, whenever you divided both side by -2, the sign will get changed. Okay, the sign will get changed. Okay, so here it will be in this way. This minus will get cancel, and so 4 divided by 2 it will be 2. Okay, so you may understand in that way. Okay, or you may understand in this way, whenever it's the negative number goes in the division, what happens? Whenever the negative number goes in the division, the sign of inequality changes. So this sign I have changed. So if I solve it further, I'll get x is greater than equal to -4 divided by -2, it's +2. Minus will get cancelled and 2 2s are 4. So which option it is? X is greater than equal to 2. This is option number 4. X belongs to the real number. I hope it is quite clear and you are able to understand this based on rule number 4. So whenever you divide by a negative number, the sign of inequality changes. Let's move ahead. Yeah, the next question we have, that is 7 minus 3x is less than x minus 5. What will happen, children? Transfer variables to one side and numbers to one side. -5 will go to this side, becomes +5, and x minus 3 will go to this side, becomes +3. So whenever there is this like this transfer, rule number 1 and rule number 2, there will be no change in the inequality sign. So 7 plus 5, it's 12, less than 3x plus 1x, it is 4x. So this 4 is in multiplication. If I transfer it to this side, it goes in the division. So can I say here it's 4 ones and 4 threes are? Yeah. So do the sign here changes, children? No. When it is divided by a positive number, there will be no change in this inequality sign. Okay. Only the sign will change when you are going to divide it by the negative number. So which option it is? It is C, x is greater than 3. X is greater than 3. So option number 1. Sir, now you will say that this option is not present only. Beta, see this. You said it is x is greater than 3. So you can write like this also, no? The meaning of this and this both are one and the same. Okay, so you have to see according to the option. So x is greater than 3. Sir, here signs of inequality are changing. They are not changing, just observe it. Okay, just we are changing these values towards this here and there. Let's go ahead for the next question. Yeah, so the equation we have, children, x 8 minus x in bracket 8 minus x is greater than 0 and x belongs to natural number gives. Come on, let's solve it. So children, can I say here this x 8 minus x, this both are in multiplication. So what I'll do, I'll just like product law, I'll solve this. I'll consider this with this and this also with this. So I'll say that x is greater than 0 and here I'll say 8 minus x is greater than 0. Okay. So this minus x, what I'll do now, see minus x I'll transfer to this side. So can I say that minus x will go to this side, become plus x. So 0 plus x, it will be x only. Now here the sign will not change. So just remember, when you are transferring positive to negative and negative to positive, the sign will not change. Only the signs will change when you divide or multiply. Now, so children, see, we have the values of x as x is greater than 0 and here in the second I have x is less than 8. So which option is there where, see what I'll do, I'll combine it so that it will be more clear to you. I'll write here like this. This are x. This x is greater than 0. Is it? X is greater than 0. This crocodile face, it is towards x side. So x is greater than 0. So I have written here x is greater than 0. And here it is x is less than 8. it means 8 is greater than x. So I'll write here 8 is greater than x, or you can say that x is less than 8, both ways. See, you have to understand the concept. Don't rectify the things, else you will not understand the things. Understand the concept. Once you understood, you can write in any way. Now here it is said x is greater than 0, so write in this way, x is greater than 0. And here it is 8 is greater than x, or x is less than 8, write in this way. So which option it is satisfying this one? Yeah, I am able to see this third option. Okay, x is greater than 0 and x is less than 8. I hope it's quite clear to you. Let's go ahead to solve the next question from the exercise. Yeah, now it's very easy. This question is based on the rules. You have to say whether these are true or false. Yeah, so see the first question, it's given that here it is given x is less than minus y. Okay, now what it is done, children, see, this is your question. Now what it is done, we have changed the sign on both the side. See, the question was x is greater than minus y. So now here in the solution, this is the solution side. Okay, this implies, this means implies this is the solution. In the solution it is said that this is minus x and they have changed the sign and minus y has become plus y. Now the question is to you, this has changed. Now is it true or false? Now children, you see, this was plus x, it becomes minus. It was minus y, it becomes plus y. So both the sides, the signs are changed. So when both the side signs are changed, this sign has to be, the sign of inequality has to be reversed. This was our rule number, rule number 5. So the sign of inequality has to change. So here it is already changed. So it is true or false? So yes, it's true. Okay. When you multiply both the, when you change both the sides, both the signs of this, both the terms on either side. So if you change both the signs, the sign of inequality will change. Okay, this was our rule number 5. So this is true. Now let's see the second question. In the second question, the question is given to us. This is the first one. Now in the second we have, it is given minus 5x is greater than equal to 15. This is the question. Now what is done, children? See, this becomes x greater than equal to minus 3. This has become. So what is done actually here? Both sides are divided by, now see, both sides are divided by minus 5. How you will get this x and minus 3? When you divide both side by minus 5. So if I divide both side by minus 5, so come on, say me, what happens when you divide any, when you divide both the sides by the minus or the negative number, what happens? The sign of inequality has to be changed. So here the sign of inequality, is there any change in the sign of equality in the solution? See, no, the sign is same. Actually, when you divide it by the negative number, the sign should reverse. The sign should become like this. So here there is no change in the sign in the solution. Is it the change in the sign in the solution? No. So this answer is false. Okay, so when you divide both the sides by the negative numbers, the sign of inequality should reverse. Okay, which here it is not done. Now you see the third question, 2x is less than equal to minus 7. Now these both sides are divided by minus 4, minus 4. These both sides are divided by minus 4, minus 4. It means divided by negative number. So when you divide by negative number, the sign of inequality should reverse. Is it changing? Yes, it's changing here. It means it's true. Now here 7 is greater than 5. Both are the reciprocal. So when we did reciprocal, the sign of inequality has to change. Is it changing here? Yes. So it's also true. So only one we have as a false. I hope, see, this complete true and false and everything depends on our 6 rules. So understand that first and then go for solving the questions. Let's go ahead to solve the next question. So state whether the following statements are true or false. So see the first question we have, children, here. If again here you have to say whether it's true and false, and it again depends on that 6 rules. Okay, can we recap that first 6 rules? Okay, fine, just we'll recap quickly. In the first, second and third, in these first 3 rules, the sign of inequality was not changing. In fourth, fifth and sixth rule, the sign of inequality was changing. In the first rule, what it was, when plus will go to other side, it becomes minus. Second rule was when minus will go to other side, it becomes plus. Third rule was when you divide and multiply both the sides by the positive number, the sign of inequality will not change. Okay, these are the first 3 rules. Rule number 4, when you divide or multiply both the sides by the negative number, the sign of inequality reverses. Then rule number 5, when you change when you change the sign of both the sides, the sign of inequality reverses. And rule number 6, when you take the reciprocals, the sign of inequality reverses. So these are the 6 rules. So let's see here, children. Now it's given that here A is less than B and then A minus C. Now from the both terms you are subtracting minus C. Now here whether the sign of the inequality will change when there is a subtraction on both the side, do the sign will get changed? No. So here it is as it is written here. So the first statement is true. Okay, then see the next one. Here it is given A is greater than B and you are adding the on both the sides. So for addition and subtraction there will be no change in the sign, and here also there is no change in the sign. So that means this is also true. Okay, the third one, A is smaller than B, then when you multiplied both the side by positive number, whether the sign of inequality changes? No, the sign of inequality will not change, but here it is changed. That's why this is false. Okay, the sign should not change when you multiply by the positive numbers. Now A is greater than B, and on both the sides what you are doing, you are dividing it by the positive number. When you divide it by the positive number, see, when you divide or multiply by the positive number, the sign of inequality should not change. So here it was A was greater, now it becomes less, and here the sign is changed. That's why this is also false. Okay, we got 2 true and 2 false. Then we have A minus C, B minus D. This is given to us. Then what it is done, children, minus D went to this side, it becomes plus D, and minus C went to this side, it becomes plus C, and the sign of inequality is as it is. So here is it true or false? Yes, it's absolutely true. Why? Because here the when we are changing the signs, like when positive is going towards negative or negative is going towards positive term, the sign of inequality will not change, and here the sign of inequality has not changed. So that's why this is true. And the last one, just let me erase this all ink so that it won't spoil our questions. Yeah, let's go for the last question. See, in the last question it is given that it is given in this way. Okay, A is smaller than B, and it is said that C is greater than 0, and C is not equal to 0. See, there is 2 information of C is given. It is greater than 0 and it's not equal to 0. It means C is a positive number. Greater than 0 means 1, 2, 3. Okay, so C is a positive number. So when I subtracted positive number from both the side, so when we are subtracting positive number from both the side, do this sign will get change here? The sign should not get change. Okay, the sign should not get changed, because when we are doing subtraction on both the side or addition on both the side, the sign will not change. But here it is changed. In the question it is given they are changed. So that's why this answer is false. Okay, it should not change. Yeah. So let's go ahead and solve the next question, children. So what we have the answers, the first 2 are true, the next 2 are false, then the 5th one is true, and the last one is false. Okay, so let's go ahead to solve the next question. Yeah, the question number 4 we have on the screen. X belongs to natural number. Find the solution set of inequations. Come on, let's solve it. The first question we have here, it's 5x plus 3, which is less than equal to 2x plus 18. So children, what we'll do, transfer variables on one side and numbers on one side. So during this transfer, do the sign of inequality changes? No. Rule number 1 and 2. Plus 2x will go to this side, it becomes minus 2x. So this inequality will remain as it is. Plus 3 will go to this side, it becomes minus 3. Okay, I have transferred this 2 to this side and plus 3 to this side. 5x minus 2x is 3x, and 18 minus 3 is 15. So x is less than equal to 15. Now this 3 is in multiplication. May I divide it by 3? Yeah, multiplication will go to this side in division. And here it is division by a positive number. Do this inequality will reverse? No. So x is less than equal to 3 5 is a 15. Yeah. Now see, we have the answer for x as x is less than equal to 5. And your x belongs to natural numbers. Now see, you should be aware about the natural numbers and whole number, children. Natural numbers, whole numbers. Natural numbers starts from 1, 2, 3 and so on. Whole number starts from 0, 1, 2, 3 and so on. Okay, so now x belongs to natural number. So x, what will be the values of x? Same then, the values of x should be less than equal to 5. So the first value of x will be 1, then 2, then 3, then 4, and it is equal to 5 also. So x, so your replacement set is natural numbers. So you can take all numbers from the natural numbers, but the condition is x is less than or equal to 5. So the value of x should be less than 5. So what are the numbers which are less than 5? That is 1, 2, 3, 4, and it is written equal to also. So you will count 5 in that as well. So when I say x is less than equal to 5, it means 1, 2, 3, 4, 5. I hope it is quite clear and it's quite simple to understand. Let's solve the second part of this question. We have here 3x minus 2 less than 19 minus 4x. Come on, let's do it, children. Yes, variables on one side, numbers on one side. Minus 4x will go to this side, becomes plus 4x. Again, do the sign of inequality will reverse here? No, it will be as it is. Rule number 1 and 2, the sign of inequality will not change. Minus will go to this side, becomes plus. Okay, so 3x plus 4x, it is 7x, and 19 plus 2, it will be 21. So this 7 is in multiplication. I'll transfer this side in division. So here it is divided by a positive number. So when I divide it by positive number, again the sign of inequality will not change. So 7 3s are 21. Now see, your x value should be less than 3. So come on, say me, what are the values which are less than 3 from the natural numbers? The first value will be 1, this and 2. Whether 3 will come here? No, it's not written equal to. It's written less than 3. So you have to take the values which are less than 3. So they are 1 and 2. So the next question we have, children, fifth one, if the replacement set is the set of whole numbers. Okay, so here the replacement set is given to us, that is a whole number. So what are the whole numbers here? 0, 1, 2, 3, 4, 5, 6 and so on. Okay, so the first question we have here, it is x plus 7 less than equal to 11. So let's solve it. That plus 7 will go to this side, it becomes minus 7. So 11 minus 7. So during this transfer there will be no change in the inequality. 11 minus 7 is nothing but it's 4. So here x is less than equal to 4. So what are will be the values? 0, 1, 2, 3. Less than 4, all these values will come, and then when I say equal to 4, so here we will include 4 as well. Then we have the second question in the same, that is 3x minus 1 greater than 8. So when that minus 1 will go to this side, see this we need to solve same as linear equations. You have done so many times these things. So can I say that 8 plus 1 will be 9. So that 3 is in multiplication, it goes here in division, and when we divide it, there will be no change in the sign. So x is greater than, so here it is, your x is greater than 3. So your solution set will be, you can say that, or the values of x can be, x is greater than 3. So your solution set will become on semi. The values which are greater than 3, they are 4, 5, 6 and so on. So this is your answer. Very simple questions they are. Let's solve the third one. We have third one as 8 minus x greater than 5. So minus x will go to this side, becomes plus x. I should have transferred that plus 5 also towards this side. So numbers one side and variables one side. So we have only one variable here, and 8 minus 5 is 3. So x is, read it how you will read, x is less than 3, because this crocodile face is towards 3. So here 3 is greater than x, and it means x is less than 3. So here solution set, the values which are less than 3. So you will have here less than 3. What will be the values less than 3? That will be 0, 1 and 2. Let's go for the fourth one. Yeah. So it is 7 minus 3x given that greater than minus 1 by 2. Okay, so minus 1 by 2 will go to this side, becomes plus 1 by 2, and that minus 3 will go to this side, becomes plus 3x. Okay, here we have not done anything, just transferring. So during transferring there will be no change in the sign. So if I cross multiply here, 7 2s are 14, 14 plus 1 15, 15 by 2. Yeah, I have got this till now. Then 3 is in multiplication. This multiplication will go here in division. So I'll be getting here, see, I'll just write the next step here this side. So it will be 15 by 2. So when this is in division, it will go here, and it goes in multiplication with the 2, the basic concepts. So now if I solve it, so 3 5s are 15, 3 5s are 15, 3 1s are and 3 5s are. So 5 by 2 I am getting. 5 by 2 is greater than x. So can I say that 5 by 2 means it's 2.5? So x is smaller than 2.5. So can I say that the solution set, so the value should be less than or equal to 2.5. So I'll write here solution set will be the values which are less than 2.5. See this, we have the whole number, so start from 0, then when 1 will also come and 2 will also come because the values are less than 2.5. So 2 will come in this. Can 3 will come in this? No. So we have the answer as 0, 1, 2. It was very easy question. Let's move ahead. Yeah. So the next question we have, children, solve the inequation. Again it's quite simple. 3 minus 2x greater than equal to x minus 12. Okay, how to do it? Again, variables on one side, numbers on one side. So what I'll do, that minus 12 I'll transfer to this side, it becomes plus 12, and variables on this side, so minus 2x will transfer to this side, becomes plus 2x. So 12 plus 3 it will be 15, and 2x plus 1x it is 3x. And do read the question here, your x belongs to natural number, it means 1 2 3 4 5. So 15 by 3, so 15, 3 5s are 15. So here x is less than equal to 5. So come on, write the solution set for this. So I'll write the solution set here. See, whenever you are writing the set, you should write in the curly bracket x is less than 5. So and the natural number start from 1. So take the values of the natural numbers which are less than and equal to 5. So 1, 2, 3, 4 and equal to 5 means 5 will also count in that. I hope it is quite clear. Let's move ahead for the next question. Yeah. So the seventh question we have, children, if 25 minus 4x is less than equal to 16, find this. Okay. So let's solve. We have 25 minus 4x less than equal to 16. Okay. How you will do it again? Yeah, numbers on one side. So plus 16 I'll send to this side, it will be minus 16 and minus 4x will become plus 4x. 25 minus 16, it will be 9. Yeah. So if I solve, it will be that 4 is in multiplication, it goes here in division. See, whenever the positive numbers are going in division and multiplication, there will be no change in the inequality sign. Lot of time we have done that. 9 divided by 4. So if I divide it, it will be, see, for the slow learners, I'll divide here and I'll write the answer. 4 2s are 8. You'll remain with 1. You give point here, it will be 10. 4 2s are 8. It will be 2, it becomes 20 and 4 5s are. So we have the value of this as 2.25. Okay, so x is greater than equal to 2.25. Now see, here two questions are asked to you. Find the smallest value of x when x is a real number. Now children, when we'll talk about real number, what does the real number means? All the numbers like natural number, whole number, integers, rational numbers, all comes under real number. So this point will also come under real number. So you have to say x is greater than equal to 2.25. So you have to find here which is the smallest value of x. See, your x is starting from what? 2.25, because it is written equal to, and then it's greater than that, 2.25. See, 2.25, 2.26, 2.27, 2.28. So it will go on that. Okay, it goes on. But here the first you have to write is which is the smallest one. So which will be the first number here when we consider the real number? Yes, it will be 2.25. The first number, that will be the smallest here. So I'll write here smallest value of x will be here 2.25. when it will be? When x is real number. Okay, so when x is a real number. And what is the next answer here then? Here we are talking about the real number. Okay, when I say you the integer, now you see your x starts from, your x is equal to 2.25 and greater than 2.25. So 2.25, it will be 2.26, it will be 2.27. It goes on, then it will be 2.5, then it will be 3, then it will be 3.1, 3.2, 3.5. So here we need the first smallest integer. So after 2.25, the first number, the first integer will be 3. So here the smallest value for the integer, it will be 3, because the first integer after 2.25, which is the first integer, that is 3. So smallest value of x will be here 3 when X is an integer. I hope you are able to understand each and everything, and the questions are quite simple. Let's go ahead and solve the next one. If the replacement set is the set of real numbers, so here the replacement set is real number. So what is the question? Solve. Yeah, we need to solve these questions. Okay, again let's solve it. So minus 4x is greater than equal to minus 16. Now what I'll do, children, this minus 4, it is in multiplication, I'll transfer here in division. Now the main important concept come here. When you divide by the negative number, what will happen? The sign of inequality will change. So there the sign of inequality is changing. I'll change the sign so that you understand it. Okay, fine. So x, if I divide it minus 16 by minus 4, it will be 4 4s are 16, that minus minus both will get cancel. Okay, so x is less than equal to 4. Now children, here you see we don't have the real numbers it's given. So how we'll write the answer here? See, writing answer is very important here. See how I write it. X belongs to a real number. Okay, this we have studied in set how to write the answer. Then comma, x is less than equal to 4. This is your answer. Simply you will say that x belongs to real number. Okay, x semicolon, x belongs to real number, and then move on. Yeah, then we have the next question here. 8 minus 3x less than equal to 20. Then what I'll do? Yes, variables on one side, numbers on one side. Minus 3x will go to this side, becomes plus 3x. So 8 minus 20 will be minus 12. 3 is in multiplication, it goes here in division. So are we dividing by negative number? No. So it's a positive number. So here it is. X is greater than equal to minus 4. How to write the answer? See, simply as I said you will write solution will be x, then x belongs to real number, and whatever is there that you write as it is, minus 4 less than equal to x. I hope it is quite clear to you. Let's go ahead to solve the next one. So children, here you may write like this also. Okay, like I have written x is greater than minus 4. So you can write this x like this also. If I want to first write first x, so I can write x is greater than equal to minus 4. So here you may write like this also. So don't get confused if you find this answer in your textbook or any in the solutions. Okay, the meaning is one and the same. Yeah, let's go ahead. So find the smallest value of x for which 5 minus 2x is less than. Okay, fine, let's solve it and get the answer. So the question is 5 minus 2x less than. Now variables, what we'll do, we'll transfer variables on one side and numbers on one side. So minus 5 by 3x, it will go to this side, it becomes plus 5 by 3x minus 2x we have on this side. Then if I solve this, children, this mixed fraction, it will be 5 to the 10 plus 1 11 by 2. 5 to the 10 plus 1 11 by 2, and plus 5 will go to this side, becomes minus 5. So let's solve it. So cross multiply here. So 5 ones are 5 minus 3 2s are 6. So 5x minus 6x upon 3, cross multiplication we are doing, and here also you do the cross multiplication. It will be 11 minus 10 upon 2. 5x minus 6x, it is minus 1x by 3, and here we have 11 minus 10 will be 1 by 2. Okay, then we have to find the value of x. Now what I'll do, this 3 here it is in division, I'll send this first in that side. So I'll get here minus 1x will be as it is, 3 will go this side, it was in division, it went in multiplication. So 1 into 3, it will be 3 by 2. Okay, now what I'm going to do, children, is something very important I have to do now, because my x should be positive, my x should not be negative. Okay, so this minus 1, what is there, it is in multiplication. If I transfer it to this side, it goes in division. So can it becomes like this? See, minus 1 means just its minus sign over here. Now if I say you the minus sign it's in division, so you can write it in the middle also, there is no problem in that. Okay, so it's minus. So what we have learned again, okay, see, for your better understanding, what I'll do, I'll write one more step here so that you don't have any type of confusion there. Yeah, so it will be 2, and that minus 1, it is in multiplication, it went in the division here, so when it goes in division, it will be in multiplication with the denominator. Okay, the basic concepts. Now here x is was, see the sign. Now whenever we divide by the negative number, what happens? Rule number 4, the signs of inequality reverses. So here I have changed the sign. Okay, this is something very very important. It is 2 into minus 1, it's not x. Okay, x I am writing like this. So if I solve it further, it will be 2 into minus 1 will be minus 2. So you can write in the standard form that minus sign in the middle. Okay, so it looks like this. So can I say that x is greater than equal to minus 1.5? This is the solution. Now what we need to find, where x is an integer, find the smallest value of x. We have to find the smallest value of x. Now what is given? X is greater than equal to minus 1.5. Children, for your understanding this, just I'll draw here number line to make you understand what does it mean. See, suppose I have the values here, it's 0, 1, and here I have minus 1, somewhere here I'll have minus 2. So it is said that x is greater than minus 1.5. My minus x is equal to also minus 1.5. So minus 1 point is somewhat here. Okay, and this x is greater than this. Greater means it will go towards this side, towards the right side. So minus 1.5, minus 1, 0, 1, 2, 3, in that way. So now you say me, which is the smallest integer for this x? So see, your numbers are starting from here, it is minus 1.5. After this, the first integer you will have, this is not an integer, integers are not in the points. The first integer will have, it will be minus 1, then 0, then 1. So here your answer should be, the smallest value of x will be smallest value of x, where x is an integer, it will be minus 1. I hope you are able to understand, because x is equal to and greater than minus 1.5. So the values which are greater than minus 1.5, it will be minus 1, 0, 1, 2, 3. The first integer you will be getting it as minus 1. I hope it's quite clear to you. Here you write smallest value of x where x is integer. Okay. Yeah. Let's go ahead and solve the next question. I think this is the last question here. Find the largest value of x for which, okay, 2x minus in bracket. Okay, fine. What we'll do, first we'll multiply this with the bracket. So I have 2x minus 1 multiplied by 9 minus x, and here it is given that x belongs to whole number starts from 0. So just multiply 2 into x, it is 2x, minus 2 into 1 is 2. Okay, then less than equal to 9 minus x. Now variables on one side and numbers on one side, minus x will go to this side, becomes plus x, and that will be minus 2. And 2x plus 1x, it is 3x, which is less than equal to 9 minus 2 is 7. So you have the value of x as less than equal to 7 by 3. Something interesting came now. So it's 7 by 3. Children, here if I see, here I did an error. That error I'll just make it correct. See, this was minus 2, and when this minus 2 went to this side, it should become plus 2. Okay, so it is 9 plus 2, and 9 plus 2, it should be 11. I'll just erase the ink. Yeah. When I just have revised it, I came to know that, yeah, it's 9 plus 2, it's 11, and 11 by 3 I get here. X is less than equal to 11 by. So now if you see, children, what we need to find the largest value of x where x belongs to whole number. So I'll write the answer here. See, it's 11 by 3 means, can you say here it's something 3 point something it will be? Is it 3 point something? And here x is less than that. Now 3 point, then 3, then 2, then 1. So here you need to find the largest value of x. Okay, and x belongs to whole number. So here if I solve this, see, I'll be getting an answer here if I divide this 11 by 3. See, this no need to write. Okay, this is just for your understanding. So it will be 3 3s are 9. So I'll have here 2, then it is point, then 3 3 6 are 18. then again I have a point that will be 2 and it goes on continuation. So I'll consider this as 3.67. Okay, I'll consider this as 3.67. Now see here x is less than equal to, your x is less than equal to 3.67. So it means your value of less x is, first it is less than or equal to 3.67, means less than this number. So after this, what will happen, it will be x, your x value can be 3.65, your x value can be 3.64, then somewhere here 3 will come, then somewhere here 2 will come, and here it is written that x belongs to whole number. So these values we cannot take as the largest value, because this is not a whole number, this is not a whole number. So which will be the first whole number, that is the first whole number, it will be, that is 3, and this is the first whole number and it will be the largest whole number. So here you will write the final answer as the largest value of x is what here, 3, because x belongs to whole number. Okay, I hope it is quite clear to you. It is 3.67. This is the number which we got the answer, but your x is less than this. So if you go back then this, so 3.66, 65, 64, then somewhere 310, 39, then it will be 3. So the first whole number will be 3. I hope it's quite clear to you. Children, I hope you enjoyed this session a lot. You understood each and everything, and I hope you have really liked the mathematics world. Thank you. Thank you so much for watching. Let's meet again in the next video. Bye bye.